So for this session, we will now consider radical expressions and then we will solve radical equations. So a radical equation in one variable is an equation involving radicals. So the definition is very simple. Okay, so an equation which involves radical expressions, then it's a radical equation. Now, let me introduce the following definition here. An equation quadratic in form is an equation equivalent in the form au squared plus bu plus c equals 0, where a, b, and c are real numbers with a not equal to 0, and u is an algebraic expression. So, for example, you can have something like a times x plus 1 quantity squared plus b times x plus 1 plus c equals 0. So, this is an equation quadratic in form. So, you see this guy here, the x plus 1 squared, and then here you have the x plus 1. So, the x plus 1 here is the u in this equation above here. Okay? Of course, this u, it can be just the variable x. Okay? If that's the case, then you have a quadratic equation. Okay? If u is another expression, you will have quadratic in form. Okay? Although, in this example, if you expanded this x plus 1 squared and then combine similar terms, you will end up with a quadratic equation. Okay? But this u here, it can be any expression. It can be another polynomial, or it can be another, or can be a rational expression. It can also be radical expression or other else. Okay, so we call them equation quadratic in form. Okay, now we note that what we do on the left hand side must also be done on the right hand side. So you apply multiplication property of equality when you multiply something on the left hand side. You also multiply the same thing on the right hand side. Or the addition property of equality, when you add something on the left hand side, you also need to add the same thing on the right hand side. Okay, now in solving radical equations, the checking part is very important. Okay, so always check that the values obtained satisfy the original equation. There are a lot of times when you've obtained some values after solving a radical equation. Some of them may not be an actual solution of the original equation. So checking part is really important, as you will see later in our examples. Okay? Now, let us look at this example. We want to solve cube root of 1 minus 2y minus 3 equals 0. Okay? Now, when solving radical equations or equations involving radical, okay, the first suggested step is to isolate one radical expression on one side of the equation and then move the rest on the other side of the equation. Okay? Okay? First step, you get one radical expression, isolate that on one side of the equation, and then bring everyone else to the other side of the equation. So from here, we have cube root of 1 minus 2y minus 3 equals 0. We rewrite it this way. So cube root of 1 minus 2y equals 3. So we move this to the other side. So we isolate the radical expression. And then next step, remember, nth root of a equals b. This means that a equals b to the n. Okay? Nth root of a equals b, it means a equals b to the n. Okay? Or maybe what you may recall is that you have the nth root of a raised to n. This is equal to a. That's one of the properties that we have. So from there, you have cube root. What we're going to do is to raise this to power 3. We raise this to power 3. Or if you use this 1 minus 2y, that's equal to 3 to the power 3. Okay? So whatever we have there, it's this. So we cube both sides. We cube the left-hand side. We need to cube the right-hand side. And doing that, we'll just have what? 1 minus 2y, because that radical with the index 3 will cancel the power 3 here. And then 3 cubed, that's just 27. And then now we solve for y. So y will be negative 13. So how did that happen? So from here, let us write it here. You have 1 minus 27. This is equal to 2y. So you will have minus 26 equals 2y minus 26 over 2. This is equal to y. And negative 26 over 2, that's your negative 13. Okay? Now, we have the value for y. What's left to do is to do the checking part. When y equals minus 13, we have cube root of 1 minus 2 times negative 13 minus 3 here. Okay, so we are substituting the value of y here in the original equation. But you will have negative 2 times negative 13, that's positive 26. So 1 plus positive 26. We have cube root of 1 plus positive 26 minus 3 in here. We have here cube root of 27 minus 3, and we know that the cube root of 27 is just 3. So 3 minus 3 equals 0. So we have the equality here. The equality is satisfied. Okay? Question for this?
Sir, could you please go back to where we get negative 13, please?
So well, we get negative 13. It's in here. So we move this to this side, and then we move the negative 2y to that side.
Okay, sir, thank you.
You're welcome. Okay, let us work on the next problem. Here, we have square root of 2x plus 3 minus square root of x plus 1 equals 1. So, on the left-hand side, we have two radicals. Square root of 2x plus 3, the other one is square root of x plus 1. And I said earlier, what we do is to isolate one radical on one side of the equation and put everything else to the other side. Okay? So our first step here will be this. So we move this minus square root of x plus 1 to the other side. So on the left-hand side, we just have square root of 2x plus 3. On the right-hand side, we have 1 plus square root of x plus 1. And then this is square root, so all we need to do is to square. Okay? When we square, we have this. Okay? And then let me expand this guy here. Remember your a plus b quantity squared. This is let me clarify that. This is a squared plus 2ab plus b squared. So this is your a here. This is your b here. So if we square this guy here, it's just 1 squared, okay, plus 2 times a times b. So 2 square root of x plus 1 plus square root of x plus 1 quantity squared, correct? Or this guy here, 1 plus 2 square root of x plus 1 plus x plus 1. Are we good? Okay. Okay. So that will happen on the right-hand side. Of course, on the left-hand side, the radical and the squared here will just cancel each other. Okay? So on the left-hand side, you have 2x plus 3. On the right-hand side, we expanded. Okay? And then what we're going to do is to simplify. This is the simplified form. Okay? So
Sorry, sir.
how
Could you
did we
just show
come
the
up with it?
steps already,
Sorry?
please?
Question?
Could you please show the steps that you
Yeah,
wrote
yeah,
and
yeah.
read?
That's what I'm going to do.
Okay,
So
thank you.
you have your x plus 3 here. So let me go back from this. You have this guy here, it's equal to. So for this guy, you have x plus 1 only. And therefore, you have 1 plus 1 here. Okay, so 1 plus 1, that's 2. And then in here, you have only x. So you have x plus 2 square root of x plus 1. This is your 2x plus 3. And then this guy, we move it to this. This guy also, we move it to that, to this side. So you will have 2x minus x, and then 3 minus 2. So 2x minus x plus 3 minus 2. This is 2 square root of x plus 1. So the reason why we are doing this is because we want to isolate this radical again to the one side of the equation. We want to isolate the radical on one side of the equation. So if we simplify this is just 2x minus x, that's x. 3 minus 2, that's 1. That's why we obtained this expression. x plus 1 equals 2 square root of x plus 1. And then from here, we still have a radical in here. We can do the squaring again. So we square both sides. Okay, we square both sides. And then we expand. So from here, I'll rewrite x plus 1 quantity squared. This is equal to 2 square root of x plus 1 quantity squared. So here, you expand. It's just x squared plus 2x plus 1. In here, you have 2 squared, that's 4. And then square root of x plus 1 squared, that's just x plus 1. And then this guy here, this is 4x plus 4. And then we simplify everything. So if we move this to the other side of the equation, you will get x squared plus 2x minus 4x plus 1 minus 4. This is equal to 0. And in here, you have 2x minus 4x. So you have x squared minus 2x. Okay? And then 1 minus 4, that's minus 3, equals 0. Okay? So we have this. X squared minus 2x minus 3 equals 0. And then this one, you can factor this. You can factor this into what? X minus 3, x plus 1. Okay? So you have this, x minus 3, x plus 1 equals 0. And again, for emphasis, if a, b equals 0, then a equals 0 or b equals 0. Again, just to recall this property. So we will have x minus 3 equals 0 or x plus 1 equals 0. Or that x equals 3 or x equals negative 1. Okay? And now we have two values for x. We check if these two values are actually solutions. So when x equals 3, you have square root of 2 times 3 plus 3 minus square root of 3 plus 1. You have square root of 9 minus square root of 4. So 2 times 3, that's 6. 6 plus 3, that's 9. And here, 3 plus 1, that's 4. And therefore, you have 3 minus 2, which is equal to 1. And then, when x equals negative 1, you have square root of 2 times negative 1 plus 3 minus square root of negative 1 plus 1. So this guy here, it's just 0. The other guy here, 2 times negative 1, that's negative 2 plus 3, that's positive 1. And square root of positive 1, it's 1. So both of them are solutions. X equals 3 and x equals negative 1 are both solutions. So you may now box these two guys here. Question. Let's do our next example here. Square root of 10 plus 3 square root of x equals square root of x. So notice we have a big radical in here. Inside that big radical, you have 10 plus 3 square root of x. And then on the other side, you just have square root of x. So, well, basically this is already isolated on one side of the equation, so we can square both sides as our first step. So if we square both sides, the radicals, here the big radical will disappear. Here, this radical here will disappear. So we will have 10 plus 3 square root of x equals x. Take note that this square root of x here, it's inside the big radical, so it will remain there. So if you square, only the big radical will disappear. Okay? And then we still have a radical in here. We isolate this. Okay, we isolate this. So we will have 3 square root of x. It's equal to x minus 10. So we move this 10 to the other side of the equation. It's 10 to the other side of the equation here. That's why we have x minus 10 in here. And then again, this is already isolated, so we square both sides again. Okay? And therefore, we will get 9x for this. And then in here, you have x minus 10 squared. So x squared minus twice the product, 2 times x times 10. So minus 20x plus 10 squared. That's 100. And then we can write this in standard form. So we put this 9x to the other side of the equation. So we will have what? 0 in here, you have here x squared minus 20x minus 9x plus 100. Or that you have 0 equals x squared minus 29x plus 100. Okay? Are we good?
Sir,
Yep.
where do we get the 20x? Negative 20x?
When you expanded this, x minus 10 squared. So x squared minus twice the product. So 2 times x times 10. 2 times 10, that's 20. Okay? So the formula again, a minus b quantity squared. So a squared minus twice the product plus b squared. That's why we have 20x here.
Okay. Thank you.
You're welcome. Okay. And then we move to the next step. So I already wrote that step here. So you got x squared minus 29x plus 100 equals 0. And let us practice factoring here. So in here, you have your x squared plus bx plus c equals 0. So you want to find small a, b, such that the product AB equals C and A plus B, this is equal to B. So from here, our B, this is equal to negative 29. Our C, this is equal to 100. So we want to find A and B. such that A plus B is equal to negative 29. In here, you have 100. So maybe you will try, so you want positive 100, maybe you will try 2 and 50. But if you added this, you will get 52. That's not the one we want. Okay? Maybe you will try also negative 25 and negative 4. Take note, negative 25 times negative 4, that's 100. You can take both positives, but I'll use both negative because negative 25 minus 4, this is negative 29. So this is the one we want. So the factors will be x minus 25 times x minus 4. Okay? Follow? Therefore, we have those factors. X minus 25 times x minus 4 equals 0. And therefore, we have x minus 25 equals 0, or x minus 4 equals 0, or that x equals 25 or x equals 4. So we have two possible values here, 25 and 4. We check. When x equals 25, we have here square root of 10 plus 3 square root of 25. Square root of 25 here, it's just 5. So you have 10 plus 3 times 5. 3 times 5 here, it's 15 plus 10, that's square root of 25. And that's here, the right-hand side, square root of 25. Okay? So all of these here, this is your left-hand side. And this is the right-hand side here. Okay? That's for x equals 25. If x equals 4, so square root of 10 plus 3 times square root of 4. Square root of 4, that's 2. Square root of 10 plus 3 times 2. 3 times 2, that's 6. 10 plus 6, that's 16. So square root of 16, that's not the same as square root of 4. So again, this guy here, it's your left-hand side. And this is the right-hand side. So x equals 4, right-hand side, you have square root of 4. But the left-hand side, after substitution of x equals 4, we ended up with square root of 16. So they are not the same. Which means x equals 4, this is not a solution. Therefore, the only solution is x equals 25. Okay? Question? Let us look at our next problem. Here you have fourth root of 5x squared minus 6 equals x. So here you have the fourth root of 5x squared minus 6. And then on the other side, we have the x. So the radical is isolated. Okay. Yes, you have a question? Did someone raise hand? Okay, so let's continue. So in here, we raise to the power 4. Okay. And this radical here will cancel the power here. So we will have 5x squared minus 6 on the left-hand side. And then on the right-hand side, we just have x to the 4. So if we write this in standard form, we have x to the 4 minus 5x squared plus 6. And this one here, this is a quadratic in form, an equation quadratic in form. So we can have the following. We let's say y equals x squared. So this equation becomes y squared minus 5y plus 6 equals 0. So if you let x squared, if you let y be that x squared, x to the 4, it's x squared squared. So you have here y squared. Of course, this x squared is just y. And then this guy here, this is easily factorable. Factors will be y minus 3, y minus 2. This is equal to 0. Okay? But then again, what is y? Y is x squared. So this is just x squared minus 3, sorry, x squared minus 3 times x squared minus 2 equals 0. Okay? Now, I know that some of you can do the factoring from here. So even if you don't have this step here, it's totally fine. So from here, you can jump to this factoring. Okay? If you can't see that at first, you can always do this substitution here. Because of course, this one looks simpler. It's just quadratic. So quadratic in form. Quadratic in forms are easier to solve than the actual equations. Therefore, so from here, we have that x squared minus 3 times x squared minus 2 equals 0. And then we solve for x. So we start with x squared minus 3 equals 0, or x squared minus 2 equals 0. So this one, x squared minus 3 equals 0, will get two values. And for this one, x squared minus 2 equals 0, we'll also get two values. All in all, we will get 4 values. So on this equation, you have x equals square root of 3 and minus square root of 3. For this equation, we have x equals square root of 2 and minus square root of 2. Okay? Question? Okay? And therefore, if you try to verify, the only solutions will be square root of 3 and square root of 2. These negatives here, they are not solutions. So try to verify that. Okay? One way to verify is the following. If x equals negative square root of 3, the right-hand side will be negative, correct? But the left-hand side, it's always positive. Okay? The left-hand side will always be positive. So if you have negative square root of 2, again, right-hand side will be negative, but the left-hand side will be positive. So definitely the negatives are not solutions. Just try to check now that positive square root of 3 and positive square root of 2, they are both solutions. All right. Next problem here. Again, this is equation quadratic in form. Notice you have 1 over x plus 1 squared equals 1 over x plus 1 plus 2. So if we rewrite this, it's like this. So we move this 1 over x plus 1 to the left-hand side. We also move 2 to the left-hand side. And then this 1 over x plus 1 squared, it's the same as 1 over x plus 1 quantity squared. So you can let u here be equal to 1 over x plus 1. So this equation becomes u squared minus u minus 2 equals 0. And then you can factor. Try to factor this into u minus 2, u plus 1 equals 0. And then you bring back the original variable, x. More precisely, u equals 1 over x plus 1. So here you will have 1 over x plus 1 minus 2 times 1 over x plus 1 plus 1. This is equal to 0. Okay? So that's what will happen. So instead of u, I used y in this slide. So I have your y squared minus y minus 2 equals 0. Then we factored y minus 2 times y plus 1. Did I factor the other one correctly? Yeah. So y minus 2 times y plus 1 equals 0. So either y minus 2 equals 0 or y plus 1 equals 0. And then we have y equals 2 or y equals negative 1. And then you bring back the variable x. So you have 1 over x plus 1 equals 2. Or 1 over x plus 1 equals negative 1. So it's in here. And then we solve for x. So when you solve for x, so you multiply both sides of the equation here by x plus 1. So you will have 1 is this part here. And then you will have 2 times x plus 1. So you will have 2x plus 2. On this part, again, you multiply both sides of the equation by x plus 1. So if you multiply x plus 1, you will have negative 1 times x plus 1. So that will be negative x minus 1. That's this part. And this part here, it's just 1. So we solve for x, your x equals negative 1 half, or your x equals negative 2. And then I leave you to verify that both of them are solutions. That is, if you substitute x equals negative 1 half, you will still get the equality. If you substituted x equals negative 2, you will still get the equality. Question? Okay. So that's the end of this lecture. Okay. So you can work on the pages or the exercises on pages 64 and 65 of the 016 module. And you will, yeah, that's a good exercise. Okay. Questions so far? Okay, so that's the end of this this topic here.